Electromotive force can be produced in a conductor when that conductor moves inside a magnetic field. Induction occurs when a change in magnetic flux causes a change in EMF inside a closed loop of a conducting wire. Say we have a U-shaped conducting wire with some current I moving through it. This conducting wire is placed into a uniform magnetic field that is pointing into the screen. On top of this conducting wire, we place a metal rod. In essence, what this does is close our conducting loop, creating some area within it. Remember, there are three ways to change magnetic flux, one of which is to change the area covered by the conducting wire. So if we were to move that metal rod to a new position along the conducting wire, that would change our conducting area. Since the area enclosed by the conducting wire is more, then the magnetic flux is increasing, inducing an EMF. We know from Faraday's law that the EMF is equal to the number of coils times the change in magnetic flux divided by the change in time. We also know that the magnitude of the flux is the strength of the magnetic field times the area of the conducting loop times the cosine of theta. Theta is 0, so the cosine of theta is 1, which means we can ignore that term. The magnetic flux is changing because of the change in area, but the magnetic field is uniform. We can also express the change in area as the length of the metal rod times the distance it moves. So the induced electromagnetic force is equal to the strength of the magnetic field times the length of the metal rod times the distance it moves divided by the time it takes to move. Of course, we will notice right away that the change in distance over the change in time is velocity, so we can change our expression to reflect that as well. This gives us the induced EMF of a moving conductor, but it does have the restriction that the direction of the magnetic field, the direction of the velocity, and the orientation of the metal rod all be perpendicular to each other. So a conductor with a length L moving at some velocity v in an external magnetic field with a magnitude of b will cause a change in the magnetic flux that will produce an EMF. Since the EMF is caused by the conductor moving, we call it motional EMF.